Interpret just means to explain what you see, right? So, and interpret data based on a bar chart and or histogram. So those are the two key words. I will be able to analyze and interpret data based on a bar chart and or histogram. So I want you to look at these two visuals, the bar chart and the histogram. And I want you to tell me what you notice. For example, you can notice a few things about it. You can look at the X, the Y-axis, right? You could tell me about the things you see in here, a little bit about them. Write down 3 similarities and 2 differences. There's no right or wrong answer. So analyze the 2 visuals. And I told you, you might want to look at these guys. You might want to look at what's in here. All right, go ahead and share your answer with your circle group. Okay, are you guys ready to share with the whole class? Okay, let's call on someone randomly. Let's go with Emily. What did your group notice? What was one similarity or difference?
One of them has spaces in between them and the other one doesn't.
Ooh, I like that. Does anyone have a synonym for spaces? Gaps. I love that. So, which one has the gaps? Yeah. So let's write that. The difference is the bar chart has gaps in between what? What do we call these guys? What did I say these are called? These rectangular shapes? Data? Yeah, it is. Yeah, it is our data, but what do you guys know what these are called? Like instead of rectangles, we call them, it starts with the letter B. Bars. Good. So the bar chart has gaps in between the bars. What happened? I know, mine, yeah. So the bar chart has gaps in between the bars.
And then the different shapes for different.
Yeah, whereas, let's see. The histogram doesn't. Okay, the histogram doesn't. All right, so let's go with Jaden. What did you write down?
We both have the same number of points.
Okay, so both charts have what?
Same number of points.
Okay, have same X and Y values. Write it down. So let's see. I want to see if Jaden's correct. Let's go ahead and label the X and the Y axis. So the X looks like it needs some help, right? For the bar chart, that's a 1, 3, 5. Let's look at this one. 1, 3, 5. So yeah, look. I'm able to see that Jaden is correct. Look at the Y values. From 0 to 12, 0 to 12. From 0 to 6, 0 to 6. That's awesome. Another similarity, Rylan?
They both record data.
Yeah, they both contain data. Okay, let's go with Kayla.
They're both bars.
Yeah, they both contain bars. Okay, let's go with one more difference maybe. Let's go
They're
with,
both blended in.
what happened?
They're both blended in.
Oh.
Oh, different.
They're both blended in, like, they're both shaded?
Yeah.
Okay.
Well, that's
They
the
both
same
contain
one.
bars and are shaded.
I don't know why your screen is not shaded, but.
It's just because I took a picture of it. Yeah. What's that?
They track different types of data.
Yeah. So they both. So maybe they both represent different data. So right, they both contain data, but they can both represent.
Like one shows disdain or whatever, and one shows continuous.
Yeah. They can. Oh, I like that. So hey, I like how Jackson said they can both represent different data, as in one of them can be discrete and one of them can be continuous. So that's spot on with what I wanted. Like pretty much the lesson for today is which one of these it represents continuous data and which one of these represents discrete data.
Bar chart represents discrete and the histogram represents continuous.
So you're telling me this is discrete. Let's write that down. Do you guys agree?
Yeah.
Why do you guys agree?
Because the histogram has like, it shows between like 0 to 1, 1 to 2.
Okay, so I like how you're saying from 0 to 1, and then there's no, so it's like every single number between 0 and 1 and every single number between 1 and 2. So there's like never ever, you're including the
Decimals.
decimals. Good, I like that. So this is continuous. All right, and we say we include every number, so decimals are included. Whereas, what about the other one? Do we include decimals?
They're on, no, because they're on the dot.
Yeah, so these are just the
Whole numbers.
whole numbers. 1, 2, 3, 4, 5. Do you guys see that? You can see this is just representing the whole number 1. This is representing the whole number 2, right? It's never going to include 2.3 or 2.5. It just has that specific number. Whereas this guy over here actually includes between the interval 0 to 1, 1 to 2. So it could include 1.8, 1.9, 1.99, 1.1, and all those little tiny decimals. Does that make sense?
Yeah.
Okay, good. So now that we have all that written down, let's go ahead and fill in some blanks. It says a histogram looks similar to a bar chart, but a histogram is more suitable for what kind of data? Is it continuous or discrete data?
Discrete.
A histogram?
Oh,
Continuous. Okay. Think about it. Continuous. It continues. After 1, you have 1.1, 1.2, 1.22. Bar charts and histograms. Here are a few fun facts. All right. So it says a histogram has no gaps between the bars because it shows continuous data. Let's see, what else does it say? It has gaps between, a bar chart has gaps between the bars, whereas a histogram doesn't. The horizontal axis on a histogram has a continuous scale. For a bar chart, the width of each bar does not matter. For a histogram, the width of each bar should span the width of the data class it represents. So if it's between 0 and 1, you got to make sure you draw your rectangle, right? From the width of it has to start at 0 and then it ends at 1. Okay, so we're going to talk about skew. Skew. What does that even mean?
Like the skewers that you get. The chicken.
No, definitely. It's a mathematical term, and it's when constructing a histogram. Yeah, you wanted to say something? No? Okay, so constructing a histogram is only the first step in your analysis. To analyze the data, you will have to describe what the shape of the histogram tells you about the data. Skew is one thing to look for. When data are skewed, the majority of the data are located on one side of the histogram. So let's go ahead and look at these 3 pieces of data. Okay, 3 pieces, 3 visuals. Let's start with the one on the far left. So if we look here, and let's just say I wanted to make a little curve. I would make a curve starting with where the majority of our data is, and then and then make our way towards where the rest of the data is. So the majority of our data, and then all the way towards where it goes, or the rest of our data goes. So we call this, it looks kind of like a tail, huh? Like a cat's tail. It starts here, and they're like, oh, okay, the tail seems like it's extending all the way to what side? The left or the right? Left, okay. So do you see how this, okay, let's see, my pencil's not working. I think it might have. Okay, so anyways, it's a tail, and it's pointing to, like, the majority is, or at least the tail extends all the way to the left. But what can you tell me about the majority of the data? Where does it lie?
Right.
Right here, right?
Yeah,
It seems like it's all bunched up right here.
Yeah.
A lot of people are in
That
this.
was just on that
this.
one.
But then again, we still have a little bit scattered to the left, right? So we're gonna call this, since it's got the tail extending to the left, this is left or negatively skewed. Or let's put this, left or negatively skewed.
Left.
Yep, left, right? The tail's going to the left. The tail is extended to the left or negatively skewed because the majority of our data is where? Is on the
Right.
right. We could also say this is, or can you guys see that? Let me zoom out. We could also say a few more things. Make sure you write this down. Okay, you guys done writing that?
That one, yeah.
Okay, we're gonna wait for a few more students. And I like how it's saying the tail is longer on the left. Yeah, tail is, yeah, yeah, yes. Tail is longer on the left, okay? So keywords here, left, negatively because the tail is extending this way. And the majority of our data is where? On the right. Okay, for the middle one.
It's clumped up in the middle.
Yeah, so it looks like it's all clumped up in the middle, or I like to say that we have, yeah, it's all bunched up. Okay, if I were to draw a line down here, down the middle, what can you say about the two halves?
It's like split in half. It's symmetric.
There you go. Thank you, Chris. So it's symmetric, right? There's some sort of equal parts, right? Yeah, symmetrical, symmetric, right? So data is, in other words, equally spread out or equally distributed. Okay, equally spread out on either side of the peak. On either side of the peak. I like what you said, symmetrical. That was a good word. And the majority of our data is where?
No.
Yeah. The majority of our data is bunched up in the center or the middle. Does that make sense? Maybe I'm going to do a better job of drawing this. Uh-oh. There you go. I think that's a little bit better. Okay, good. Let's go ahead and look at, well, let's highlight some keywords. Equally spread out, symmetrical, and then majority of our data is in the center. Yeah? Okay, now let's look at this other one. Draw a line down here. Okay, so what can you tell me about this guy with all the knowledge that you have?
It's going from left to right.
Yeah, the majority of our data, so let's write that down.
Is it gonna be right?
Skewed.
Positively skewed?
Yeah, the majority of our data is on the left. And the rest of our data is on what side?
The right.
The right. So it looks like our tail is extending to the right. So therefore we call this right or positively skewed. In other words, the tail is longer on the right. Do you see that? So if we do the project, you will have to go ahead and create a bar chart or a histogram, and you have to tell me, hey, it looks like it's skewed to the right, or it's skewed to the left. Or you could even say, hey, Ms. Sanchez, our question that we posed gave us data that is symmetrical. It seems like there was, that the majority of their data was like right in the middle, and everything else just was kind of symmetrical and like a little bit less than the center. So it's pretty cool. Any questions? Thumbs up if this seems pretty doable.
Yeah.
Okay. When you're ready, turn the page. Okay. So we've been looking at lots of graphs. We've been looking at the multiple representations of data. So all the questions we were posing, what kind of answers were we getting from students? What kind of answers? So all those questions we came up with in the beginning of class, what kind of answers were we getting from students? Or what kind of answers were we getting? What was one question that we asked the whole class?
For which one?
For the ones that we had in the beginning of class, and I made.
But like
It doesn't matter. Just for either one, what kind of answers were we getting? What kind of answers were we getting, guys?
How long?
the grades. How many zeros do you have?
Yeah, we were getting numbers,
Oh.
right? They were all numbers. I mean, we were either getting whole numbers or we were getting
Point.
decimals. Yeah.
We were getting numbers.
So we were getting numbers in general, right? We were not getting anything else. So it's called quantitative data. Quantitative data. So the root word is quant, like quantity, right? Like quantity. How much of this? 5. How much of that? Or in Spanish, it means cuánto, like it's asking you for a number, like how much of this or that. So quantitative data will always give you a number. On a single variable is often collected in order to understand how characteristics of a group differs amongst the group members or between groups. When we ask a question like, how old is a typical Starbucks worker, it is helpful to take a blank and then see graphically how the ages differ amongst the group. So what do you think we're going to do in order to find out how old is a typical Starbucks worker? What do you think we're going to do, guys?
Survey them.
survey. We're going to ask them, right? So let's go to the nearest Starbucks. What's the nearest Starbucks here?
This one right here.
Right by Albertsons, right? And then what's the next one?
By McDonald's.
By McDonald's, right? And which was the next one?
Delmar.
Or the one in Talega, right?
Oh, yeah,
So
I
we're
think
going
so.
to survey. But Miss Sanchez, instead of taking a trip to the Starbucks across the street, she actually did take the survey. It says the San Clemente Starbucks, located across the street from us, currently employs 28 workers whose ages are shown below on a dot plot, or in other words, it's called a frequency plot.
16 to 42.
Is this accurate?
This study is accurate. I don't know what year, but yes. Okay? It says, answer the following questions below. Before we answer any questions, if you have your highlighters out, you need to go ahead and highlight the x-axis. What does the x-axis represent? The ages of the workers. So let's go ahead and, it looks like those marks on the number line are missing a number. Yes? So why don't we fill in those numbers?
Wait, where?
What number is this? Like, what's after the 15?
17,
Oh.
18,
Because it'll help us answer the questions more quickly. And then we could do okay. I only filled in the ones where the dots were, right? The closest dots were, at least for me. It's quicker that way. Okay, so the next thing Miss Sanchez is going to do, because it makes life a lot easier, is count how many dots are in each of those columns or in each of those age groups. So in this 16 age group, how many are there? 2. And then there's 3.
4, 3,
What about here? Good.
3, 1, 2.
So it just makes life a lot easier because when we answer questions, we're just going to look at that number, right? We're going to look at the age group or a certain age, and we're going to go ahead and count how many people or employees were that age. So these dots all represent people, right? The employees at Starbucks. So question number 1, Andres, how many of the workers are 18 years old? There you go. You look here, 4. Make sure you write down 4 workers. You got to make sure you put the units. Number 2, what is the range of the ages of the workers? I told you that word was going to come up. The range. What is it?
16 to 42.
Range is we take the max minus the min. So the highest or the oldest age minus the highest age and the minus the lowest, or the oldest minus the youngest, okay? Either way works. So the oldest seems to be how old at Starbucks?
36 place, the whole thing.
Oh, well, let's first start with the
20.
oldest.
20. Oh.
Oldest, 42 years old. Minus the youngest person working at Starbucks? 16. What is 42 minus 16?
26.
All right, let's do the math, guys. You could use your brain calculator or you could use your calculator. Naomi, what'd you get?
34.
34. Did everyone get 34? Okay. Good job. You just take, at least the way I like to do it is I do 42 minus 20, 22, and then I add 4. Wait a minute. I don't think that's right either because that's not what I got.
26.
Yeah, same here. So what'd you guys do wrong? Naomi, did you plug it in your calculator wrong? I got 26 as well.
No, I didn't.
Yeah, it's 42 minus 16. That makes 26. Yeah. I don't know. I used my brain calculator and then I used my calculator. Okay. Would you consider this distribution symmetric?
Nah.
Why not? Let's see. Let's draw a little curve where majority of our data. Okay. Does this look like it's symmetric?
Yeah.
No, definitely not. Because if it was symmetric, the majority of our data would be where?
In the left side. Middle.
If it was symmetric, your majority is in the middle, right? In the center, and then everything else, right, kind of falls into the left or to the right. Here, what kind of, is it left skewed or right skewed?
Left skewed.
Where's the tail longer?
On the right.
So it is,
Positive.
it's right skewed. Because the tail is longer.
Where it's at.
No, it's right skewed.
Positive. Positive, right?
Right or right.
Are you doing number 3? I can't see it.
Positive. Skewed. Right or positive skewed? Positively skewed. Let's see. Okay. The majority of our data is on the left side. Okay. But the name goes with where the tail's going. Okay. The name goes where the tail.
What's the definition of skewed?
Skewed, we just went over it up on top. It describes the shape. Good question. Describes the shape of the histogram. What happened?
No.
Who is it? Oh yeah, David. Okay, I know. It's okay. He's allowed. So is this symmetric or not?
Not symmetric.
So not symmetric. Because the majority of the data is where?
Is on the left.
So therefore we got a name for it. It's right skewed. Okay, right skewed. Okay, if I tell you the mean or the average age for a worker is 22 years old, what is the average? Why is this average not representative of a typical worker? Let's look. Well, okay, hold on. Before we answer, let's look. Everyone wants to see the 22s here. Do you think that age, you think that every employee is around the age of 22? Or is 22? There's only one person that's 22. What would be a better number that would represent this? Like the majority of the workers are between what ages?
20.
Somewhere around here, right? I think Rylan said between 16 and 22, around there, right? That's like more, at least 22. It's like, that is only one person. The rest of them are located to the left of that. So the majority of the workers are younger than 22. At least that's what we're seeing. Majority of workers are younger than 22 years. Does that make sense to everyone? That's kind of cool. We were able to create it, and then now we're able to answer questions about it. So now what we're going to do is look at this example. It says, a farm is studying the weight of baby chickens after 1 week of growth. They find the weight in ounces of 20 chicks. The weights are shown below. Construct a dot plot on the axis given. So they give you the list. So here's the list. They collected data, right? They got 20 chicks. They weighed them. They put them on the scale. And they're like, okay, this is what I found. Can you tell me or visually represent this list using a frequency plot? I'll start you off. I don't see any chicks that weighed 0 ounces, so I'm not going to put anything right here. What I'm going to do instead, look for the 1 ounces. So how many chicks weighed 1 ounce?
2.
1, 2. So put 1, 2. And then label it. That was 2 chicks. What about 2 ounces? How many?
3.
3. 1, 2, 3. And keep going. Is this discrete or is this continuous data?
Actually, discrete.
Discrete, right? Yeah, because they were just like, all right, they rounded, most likely, right? They're like, okay, let's round to the nearest whole number, which is okay. When you're done, please put your pencil down. Okay. Does yours look similar to mine?
Yeah.
Pretty cool stuff, huh? How many chickens weighed less than 3 ounces?
5.
Yeah, right, because less than 3, we're like, okay, we're not going to consider these, and we're like 3 plus 2 makes 5. Now, how many chicks weighed more than 6 ounces?
1.
Yeah. Now, how many chicks weighed more than or equal to 5 ounces?
2.
6.
More than or equal to 5.
Yep. So it's 3 plus 2 makes 5 plus 1 more is 6. Remember, these dots are representatives of the chickens. Okay? Okay, so you guys are able to answer that. And how would you describe the shape?
Symmetrical, right?
Oh, about, right? About a little bit, right? You look
It's
like
never gonna be perfect.
it's never going to be perfect. So you say it's pretty much symmetrical, I'd
That one's
say.
an outlier. That one's right.
Ooh. Why do you call that an outlier? Have you guys heard that before?
Last year.
This is different than everybody, so we should like discriminate.
It's different than
against them.
everyone. Okay, I like that. It's kind of way out here, and we're like, wait, but why are you so? It's kind of like siblings, right? If someone had like 12 siblings in here, we'd be like, whoa, you're an outlier. Because not a lot, it's like the average is not there. If we got rid of that one, we'd be like, okay, this is like typically between 0 and 5 siblings. That's usually like the average. Whereas you say 12, you're like, okay, that's a little bit out there. You're the only one, buddy. Okay, so anyways, let's go ahead and turn the page.
Number 9.
Yeah, so let's look at the time. We're doing great on time. So the following histogram shows the ages of the Starbucks workers from the first example, but in a different format. Answer the following questions based on the histogram shown below. Okay, what I want you to do when you look at any frequency plot and any bar chart or histogram, you always got to find the height of the bar, okay, and what you're talking about. So, all right, the height is equal to the number of workers, and then what about the X? The X is the age ranges of the workers. So they kind of just put them, if you were between 16 years old and 18, they just put you all in one category, yeah? So how many workers were between the ages of 16 and 18? What's that number right there?
9.
Good job. And what about the other height for 19 to 21? The height is
11.
and then we get 2, 2, 1, 1, 1, 1. Okay. Great. We're ready to, actually, what's another thing? Let's describe this histogram. Is it left skewed? Is it right skewed? Let's go with Chris. Can you tell me is it left skewed or is it right skewed, Chris?
Left skewed and
Really? The tail is going to the left?
Oh, sorry,
Right. When it's right skewed, there you go. I want to say negative because when you're the right, it's positive. Okay, so right or positively skewed.
Is there one called for the bar? Like that the bars being on the left? Is there anything?
That just means the majority of our data is on the left. That's just what it means. Okay. Now let's answer. How many workers have ages between 19 and 21?
11.
Yeah, you see how quickly that was for you to find, right? You just looked at, the first thing you looked for was this guy, 19 to 21, and you said 11 workers.
No, it's the other one, the other chart.
If the average age was 22, how many workers are younger than the average age?
9.
Think about it. If we know the average, so the 22 mark is right here, right? That's where 22. We want to see how many are younger than the age of 22. So younger means you're over here. You're 16, 17, 18, 19, 20, 21. So how many workers are there?
20.
9 plus 11 equals 20 workers.
We have 40 more minutes.
Okay, good. So 20 workers. Now let's look at the next one. What is the disadvantage of a histogram compared to a dot plot? So we looked at the dot plot, but now we're looking at the histogram. So what are some cons, or why is it that this histogram is not very yeah, just what are some negative things, I guess, about it? Yes, let's go with Jackson.
It's not as exact. Like there could be like 11, 19-year-olds and 0, 21-year-olds.
Okay, good. So it kind of like categorizes it. So you don't know how many, since we know there's 9 of them, right? We know there's 9 workers, but we don't know if those 9, if some of them are 16, some of them are 7. We don't know how many, right? Yeah, we don't know how old those workers are exactly. So that's what we need to write down. So that's a disadvantage. The ages can vary or differ. With decimals too, right? With decimals. And age can differ with decimals between 16 and 18, for example. The ages are not specific. I think that's what you guys all said. The ages are not specific. Okay. Does the histogram have any advantages over the dot plot? Like, all right, that was...
Easier to see.
Yeah, what's easier to see?
Bar graph.
It is easier, and it's a histogram, buddy. It is easier to determine what?
The chart, the graph. You said histogram?
This is a histogram, so it's easier to determine what?
This one's easy.
Easier to determine what?
Data.
No, look at what you're measuring. The y-axis always tells
The
you.
number of workers.
Yes, it's easier to determine the number of workers. Why is it easier? Well, let's say you had a dot plot with 100, hypothetically speaking, 100 employees at the age of 29.
You wouldn't.
You would look at all the dots. Would you want to count all the dots?
The numbers wouldn't even be on there.
Yeah, right? So it's better to have the numbers could if you did increments of 10, right? 10, 20, 30. So it's always easier for you to read the height of each bar, right, on a histogram than counting all the dots, right? So it's always easiest. Thank you. You're welcome. Okay, so anyways, there's some disadvantages and some advantages. We got to know them all. So let's look at this example. It says the 2016 to 2017 Arlington High School varsity basketball team had an excellent season, compiling a record of 15 wins and 5 losses. The total points scored by the team for each of the 20 games are listed below in the order in which the games were played. So here's your list. Our goal is to make a histogram, right? We're going to categorize. We're going to group the 40 to 49 points, the 50 to 59 points, the 60 to 69 points, and so on and so forth. So how many games scored, how many games were recorded where the score was 40 to 49? Let's see. I get 1, 2, 3. I get 3. So 3 tallies. That means that the frequency is 3, right? The amount of times that they scored a 40 to 49. and then I look at 50 to 59. You need to do this, so make sure you look at the 50s. 1, 2, 3, 4, 5, 6, 7, 8. Did you guys get 8?
Yeah.
Okay, so make sure you're doing that. I don't see your paper with work on it. Then keep going. Okay. 1, 2, 3, 4, 5, 6, 7, 8. I know. What about the next one? 1, 2, 3, 4, 5, 6. 2. All right. So now what we can do is to create a histogram from the table, we have to go ahead and make sure our x and y axis are in the correct units, okay? So what do you think would be a good, would be good units for the y axis? Counting by what? By ones, by twos, by threes?
By one.
Or the y axis is the number of games, right?
There's only 8, the max, so just ones,
Yeah, number of games. So yeah, the max is 8, so you're like, oh, might as well count by
Yeah.
ones. Right, where this is our max number of games. What about the categories? Okay, it's from 40 to 49. So maybe this can be the start, 40. And then this guy could be, the 50.
60, 70, 80.
Yeah.
Might as well put them in, no?
What do you mean?
Like put 45, 50.
55, 60.
Yeah, like this, watch. So right now I'm doing 40, 50. I mean, I'm not going to do the in-between because it's from 40 to 49, right? So what I'm going to do now is from 40 to 49 is there, right? Right before, so this is the last number right there. And then from 50 to 59, that's the last number right about here. And then 60 to 69, right? Because the next mark
70.
is the 70, right? So you got to make sure you include, in your interval is 60 to 69. And then 70 to 79, 80 to 89, and then 90 to 99, and then the 100. We don't have anyone in the 100. But do you guys see this? How we have the 70 mark, the 60 mark, right? Okay. So how many scored between 40 and 49? What was the frequency? And these are all together pretty much. 3. So what we're going to do is... That's 3. Put the count at the top. 3. And then what about for 50 to 59?
8.
There we go. See if you can do the rest. Okay. And then, let's see what other color. And then 1 here. Yeah? Should I highlight these so I can highlight them? Is that what you got?
Yes.
Good. Okay. And then from here, you're able to answer certain questions, right? Like, what kind of questions could I answer, guys?
How many average?
What's the most?
Okay, the one that you see the most. I like that. And then what about this? Is it,
It's
where's the tail going?
positive.
Or what's that word?
Skewed.
Right, skewed.
Oh,
Or positive skewed.
Vice versa.
Not right now. Hold on. Okay, so we have all of this. Okay, so does that all make sense to you?
Yep.
Okay, good. So we're going to be doing that a lot, okay? And I just need you guys to be able to go from a list to a dot plot or a frequency plot, a table, to a histogram or bar chart. Turn the page when you're ready. Okay, this is the exit ticket. I know it says homework number 1. I'm trying to give you guys less homework. So this is the exit ticket. It says, a group of 30 students took a test with a maximum mark, with a maximum score of 8. Their scores are listed. So here's the list of numbers. Here's all of them. And they created a table for you. And they created a bar chart for you. I need you to determine if this data is discrete or continuous. I want you to tell me what the right-hand column of the table represents. So what does this guy represent? The F stands for frequency. All right. And that's the right-hand column of the table. By looking at the bar chart, what does the x-axis represent? So what does this represent? And looking at the bar chart, what does the y-axis represent? Okay, what does this guy represent? Now, why do you think we used a bar chart instead of a histogram? So write that down in complete sentences, right? Make sure you answer, how do you know that it's discrete or continuous? I'll give you a hint. Frequency, right, is the number of times that you see, for example, you saw the score of 0 one time.
No half
You
credit.
saw no half credit. You saw the score of 1 2 times.
Is this all our homework? Right?
Your homework is pages
11?
11 and 12. And then we're going outside for the for this activity for
When
page
tomorrow?
13.
I mean, Friday.
Friday, yeah. I know, it's pretty nice, huh? It's nice, it's nice. Come on, is it discrete or is it continuous? How do you know if it's discrete or continuous? You gotta look at the list, okay, guys? Thank you. I'll see you tomorrow? Okay, good. This one too.
Calculus?
Topics, yeah.
That's calculus hard.
Yeah, dude.
No, if you can do this, you can do that as well. No, it's like this.
This is
Easy.
all you do?
This is all you do.
Junior year?
You just have to write about like a little bit incomplete sentences and maybe elaborate a little bit, you know? But
I want to be a first one.
yeah, well, it'd be nice to know some stats about
So,
your
wait, can you tell me what
about your
discrete and continuous means again?
for your athletes. There you go.
Can you tell me what discrete and continuous means again?
Yes, guys, what does discrete and continuous mean again?
Whole number.
Whole numbers is for which one?
You're discrete.
Yeah, so discrete is for whole numbers. Continuous, like a continuous number line, it goes on forever. That is including decimals. Okay, so what is this? What kind of, well, yeah, they're all whole numbers. So this is what? Discrete. And then make sure you write it in a complete sentence. Yes, David, what's up? Not right now. All right, no more bathroom breaks because then you miss out on the material, all of you, and then you come back and then what? I don't understand anything. So discrete because the values or the scores are whole numbers. No decimals. Okay, let's go with Carlos. What does the right-hand column of the table represent?
The score of like
Class scores.
Well, I wouldn't say the right-hand column. I'll be more specific. What are we talking about? What are we talking about? Are we talking about like workers at Starbucks or?
We're talking about the test.
The frequency.
We're talking about the students. Shh. Right? We got to find the noun. The noun is students. So the right-hand column is talking about the number of students, right? Because it's a number of students who scored what? Who earned each score, right? Who earned each score. For example, one student, if I put the word in, one student scored a 0. 2 students scored a 1. And you could write that word in front of the, after the 2 or after the number to get like what you're talking about, okay? For the Y. Okay, does that make sense to everyone? Yeah. Okay, so let's go here. By looking at the bar chart, what does the x-axis represent, Rylan?
The score.
it represents the frequency. Wait, you said number 2 or
The number 3.
Oh, the score.
Yeah, so the x-axis represents the different scores, right? Emily,
Yeah.
let's look at the next question. Can you answer it for us?
It represents the amount of people.
Not quite what I'm looking for, because you got to be more specific for
The
people.
students.
Yeah, so the number of students who what?
Participate or took the test.
The number of students, no, it's even more specific than that. It's the number of students who what? It's the same thing as this guy. So the Y here is the same thing as the Y over here, right? So what did the Y column represent in the table? Because it means the same thing on the
Frequency
graph.
Score.
the number of students who earned that score, right? Okay, so I don't want you guys to ever miss that, because frequency is the number of students who earn that score, and it's also represented over here on the y-axis. This is X for score and Y is for frequency. How many times did you see that score, right? How frequently did you see it? Okay, why do you think we used a bar chart instead of a histogram? Let's go with, let's go with Andres.
Don't even look like paper. I don't have it down.
We used a bar chart instead of a histogram because do you know?
Is it more precise because of the value?
What values? We have X values and we have Y values. Which one? It's because it's discrete. And why is it discrete? Discrete.
Don't tell this kid the answer.
I don't want to cheat. I don't want to cheat.
Okay, Jaden, why is it discrete?
Oh, because of its whole number.
There you go. So we used a bar chart instead of a histogram because we have
Whole numbers.
whole numbers. You guys got to make the connection here, okay? Bar chart, whole numbers. Histogram, we use it more for continuous data. Okay, so let's go ahead and look at the homework on the next page.
When do we get our break?
In a little bit. Well, we're going to play the game instead of the break because or else we won't have time.
Oh,
I used to rush him essentially.
So number 2, all right, I want to answer it with you. It says, which of the following is closest to the percent of households that have 4 devices. So first of all, percentage, you always look at the part over the whole. I'm sure you did that in Math 8 and Math 7. Part is a piece of the whole. So what's the piece here? So we have the part over the whole, or in other words, the total and the part, right? So how many had 4 devices? 4 devices. I look here, 4 devices. I have 8 over what? What's the total number of devices? Do they tell you at the top?
30.
30. So then you put it over 30 and you get a decimal and it ends up being B. If you round, approximately. Okay, so around there, right, it's repeating. Okay, so go ahead and we're going to play Gimkit. Don't forget to do your homework.